Let's talk about the centering matrix in Stata. So you remember with the centering matrix, we have a formula, which is Q equals our identity matrix minus 1 over n, and that is times the J matrix. So we need to do matrix input and input our identity matrix. Now the identity matrix, as you may recall, has 1s on the diagonals, so it may be a little tricky looking at it this way in Stata, but we have a 5 by 5 matrix, and so the first one's going to have 1, the next row, the second one's going to have a 1, then the third one, and the fourth one, so 1, 2, 3, 4, 5, and then the last one. Okay, you can't see that all on the screen, but let's take a look at that in the output to the left here. We see we have 1s on the diagonals. Now we need to do matrix input for J. And J is just 1s. So let's copy and paste that 4 times. 2, 3, 4. And let's also take a look at that to make sure that we have it correct. Okay, which we do. Now, just as we did in the previous video, since we have a formula, we can do matrix define. We want to define Q. So I'm just going to copy and paste our formula, and we need to input n, which we know is 5, it's the order, and we're going to do matrix list Q. Let's take a look at that here. Alright, so it looks like our centering matrix Q, it's got the values of 4/5 on the diagonals, and everywhere else it has -1/5, which is what we got by hand. Now we did one more step by hand. It was center matrix Y. So we're going to do matrix define little y equals our Q times our big Y. And let's look at that. So it gives us the values 0, -4, 1, 3, 3, -2, 1, 3, 0, -1, 1, 2, -3, -3, -1, which is what we had originally. If you saw the previous video, those are the values that we had when we created a matrix of deviation scores from a matrix of raw scores, our raw scores being our big Y here. There you go, that's how you use the centering matrix Q. And I hope you have a good day.